Now in this video I'm just gonna basically focus on projections. So now we have two types of projections. We can have a vector projection, and we can also have like a scalar projection of that. So now, what's a vector projection and what's a scalar projection? Now let me show you an example. Like let's say I have vector A and then I have vector B, like that. So now I can project vector A onto B. I can project vector A onto B. So how I write that is I'll say project A onto B, right? You can see that with an arrow there. So this will just be projection of A onto B, and that's given by like a formula: A dot B divided by the length of B, square that, and you multiply by vector B. So that will be the projection of A onto B. So that's a projection of A onto B, because you can basically see that we're taking this vector to lie somewhere on B. So that will be A onto B. And then similarly you can have like you can project B onto A, and you'll have something like this. This will be the projection of B onto A. So similarly, this can be given by a formula: A dot B, then you divide that by the length of A square, then you multiply by vector A. So that's how you get projections. Okay, so now let's say I have like vector A. Let's say I have vector A, and it's given in direction vector form. Let's say I have 1, 3, and 1, 3. Okay, well, let's say 1 root 3, 0. Yeah, let's say vector A is given by 1 root 3, 0. We have vector B given by root 2, 1, and 1. Yeah, so let's say we have these vectors. So what is projection? What is a vector projection of A onto B? What is the vector projection of A onto B? So this will be given by the formula: projection of A onto B. This will be A dot B. Then you divide that by the length of B squared. Then you multiply that by vector B. So that will be projection of A onto B. So now A dot B, that will just be 1 by root 2. That's just going to be root 2. And root 3 by 1, that's just going to be root 3. And then 0 times 1, that's just going to be 0. And you divide by the length of B squared. What's the length of B? So it's just going to be 2 plus 1 plus 1. For the square root of that, it's 2. Then you multiply that with, this isn't supposed to be dot, just denotes multiplication. So you multiply that with vector B. So it's just going to be root 2, 1, and 1. So what happens when you multiply that? You should get a vector, since this is like a vector projection. So now you have root 2 plus root 3 over 2 multiplied by root 2. So that's just going to be like 2 plus root 6 over 2. And then you're going to have root 2 plus root 3 over 2. Then you're just going to have like root 2 plus root 3 over 2 also. So that will be a projection of A onto B. Similarly, you can like get a projection of B onto A, right? Try to see like if you can get that one. So this one will be root 2 plus root 3. Since it's A dot B, it remains the same. Now instead you find the length of this one. So that's just going to be 4 as well. So it's going to be 2. And now you multiply that with vector A instead. So you multiply that with vector A, which is just going to be 1, root 3, and 0. So now projection of B onto A will be given by root 2 plus root 3 over 2. And then you have root 6 plus 3 divided by 2. And then you have 0, like that. That will be the projection of projection of B onto A. So keep in mind, these are vector projections. Now we can also have like a scalar projection of that. That will just be given by Now let's focus on scalar projections now, since we did vector projection. Now for scalar projection, let's say I have vector A and I have vector B like that, vector A and vector B like that. So now the scalar one for A onto B will denote that with comp. Right? Then we'll have comp A onto B. So that will be denoted by A dot B divided by the length of B. So now if we are doing a scalar projection of B onto A, notice that for scalar we don't have directions. Right? It's directionless. So now let's say we are projecting B onto A. B onto A. That will just be A dot B multiplied by the length of A. The length of, basically, is the length of this. So now this is a scalar projection of A onto B, and this is a scalar projection of B onto A. So it's just a similar case of that. So now let's say maybe I have vector A given by 1, 2, and 3, and then I have vector B given by 1, root 2, and 1. So what's a scalar projection of A onto B? Try to see if you can get that one out. So now you're just going to basically dot this to 1 by 1, which is just 1, and 2 by root 2, that's just going to be 2 root 2, and then 3 by 1, that's just going to be 3, and then you divide by the length of vector B, which is just going to be 1. 1 squared is 1, root 2 squared, that's 2, 1 squared, that's 1. So you have 1 plus 2 plus 1, which is just going to be 4, and the square root of that is 2. So 1 plus 3, that's just going to be 4. So you have 4 plus 2 root 3 divided by 2. And then you're going to have 2 plus root 3. And that's a scalar projection of A onto B. Now try to see like if you can get a scalar projection of B onto A using the same vectors right here. Thanks for watching. Don't forget to share and subscribe. And now if you look at this one, let me just show you like what you're going to have. You're going to have the length of A. The length of A is just going to be 9 plus 4, which is 13, plus 1, that's 14. Then you have root 14. Then you have the square root of 14. 1 plus 2, 3, plus 3, divided by root 14. And that's what you're going to have. So you have 4 plus 2 root 3 over root 14. And you can rationalize that if you want.